Tonight we're focusing on another important skill, adding and subtracting rational numbers that are fractions. In our first example, we have a mixed number. Mixed numbers can be complicated, especially to subtract, if we don't remember to turn them into improper fractions. So for our first problem, number 1, we're going to turn the first term into an improper fraction. And if you forgot how to do this, we accomplish this by multiplying our whole number by our denominator and then adding the numerator. So 3 times 5 is 15 plus 1 is 16. And it continues to keep the same denominator. We can go in the opposite direction back to a mixed number by seeing how many times 5 goes into 16. And it goes into 16 3 times with a remainder of 1. So we would get back to 3 1/5. Now we can set our second term down next to our first term, so 16 over 5 minus 2 over 15. And again, we're not quite ready to subtract because we do not have the same denominators. When we multiply and divide, we can have different denominators, but when we subtract and add fractions, we have to have the same denominators. So here I'm going to look and see what my least common denominator would be, and in this case it's going to be 15 because 15 goes into 15 one time and 5 goes into 15 3 times. So I'm going to go ahead and bring down my new denominator for both fractions, and since I'm not changing the fraction on the right, I'm going to go ahead and bring down its numerator as well. Now I have got to set these two fractions proportional, and I multiplied 5 times 3 to get 15, so I need to multiply 16 times 3 as well, and that will give me 48. Now my two fractions are proportional to each other, and then my two terms in the expression have the same denominator. All that's left to do is to subtract. So 48 minus 2 would give me 46 over 15. Our final step would be to make sure that our answer is in its simplest form. And since I don't see any factors that would go into both the numerator and the denominator, I think we're okay on this one. You should be able now to do 2 and 3 on your own. Let's go ahead and walk through number 4 just to get another example. So on number 4, again we have two terms in our expression that have different denominators. And so I want to find out what my common denominator will be. In this case, 8 and 3 really only have their multiple in common, so 24. And now I need to ask myself, whatever I do to the bottom, the denominator, I also have to do to the top for each term in the expression. So 8 was multiplied 3 times to get 24, so I need to multiply the numerator times 3. 3 times 3 is 9. Just like I did in class, I tend to keep my negative sign attached to my numerator value. It's just something that I've done all along in math just to help me keep track of where that negative belongs. Really, the whole fraction, 9 over 24, is negative. But by attaching it to the numerator, it just simplifies some of the addition and subtraction process as we start to do it. Now on my second term, I have 3 times 8 is 24, so I need to multiply my numerator. 2 times 8 is 16, and again this was a negative fraction, so I'm going to keep my negative sign attached to the numerator. Now we can simply follow our integer rules, because I have a negative 9 plus a negative 16. Since both of those terms are negative, I know I'm going to add the value and keep the sign. So 9 and 16 equals 25, keep the negative sign, over 24 because we're keeping the same denominator. And again, off the top of my head, I don't see a factor that goes into both 24 and 25 that would allow me to simplify that. So I think we're okay with that being our final answer. Hopefully these two examples give you enough practice to be able to solve the rest of these problems on your own. If not, I'd be happy to answer any questions tomorrow in class. Have a good night.